Hello. This week we get to talk about the so fascinating, but also so terrifying topic of climate change. Because this is a geology class, we're mostly going to be talking about long-term climate change over the past billions, millions, thousands of years. But because we're humans and we also care about the human scale, we are going to end today's lecture on climate change over the human scale, right? Centuries to decades, looking into our human future. Okay. So let's get into it. So climate change and just change in general happens all the time, right? Earth is always changing. That's just, right? Earth is a geologic system with active processes that's constantly changing. One of the reasons the Earth is constantly changing is due to plate tectonics, right? We've talked about how plate tectonics are constantly shifting around the location and the shape of the continents, causing events like earthquakes and tsunamis, changing the direction of ocean currents, right? So because of tectonics on Earth, the Earth is constantly changing. And these changes can occur at different rates, frequencies, and agencies. By rate, I mean sometimes they happen very, very slowly, right? The entire continent of North America is shifting due to plate tectonics very, very slowly, right? Centimeters per year. Whereas other changes are very, very fast. For example, a tsunami would have a very rapid change, right? Just a few hours, a few days, a very rapid change. The frequency can also be different. Sometimes there is a single event that causes a single change. For example, the asteroid impact that killed off the dinosaurs. That was a single event, caused a single change. Other events can have a frequency that's cyclic, meaning that it doesn't just happen once and it's done. It happens regularly, every so often, right? For example, volcanic eruptions. Volcanoes don't just erupt once, they erupt in a fairly cyclic recurrence interval, right? They happen every 100 years, every 1,000 years, whatever it is for that specific volcano. Then also the agency of change can vary. Sometimes the change might be geogenic, meaning natural. Plate tectonics is natural, asteroid impacts are natural, volcanoes are natural, whereas other changes might be anthropogenic or human caused. For example, deforestation is human caused. Global warming, much of it, as we're going to see later today, is human caused. Right? So there can be different rates, frequencies, and agencies of change, but regardless, Earth is constantly changing. Okay. So to do a quick recap of how the Earth has changed over time. Remember when the Earth formed billions of years ago, it was molten, it was hot, it was liquid. And then as it began to cool, the iron sank into the center of the Earth, accumulating to form the core, right? So when the Earth first began, it wasn't solid and it didn't have the core, mantle, and crust like it does today. Okay. After it formed, or after the core formed and the crust of Earth solidified, then a planetary body smashed into Earth, creating our moon. Right? So Earth hasn't always had a moon. The moon came into existence after this impact, causing debris to go out into and start orbiting around our planet. Right? So that was a huge change. The evolution of Earth, or of life on Earth, was also a huge change. So Earth has not always had life. By looking at the fossil record and by looking at other geologic records of life, we think that life began on Earth about 3.8 billion years ago, about a billion years after Earth began. And due to these living organisms, we have changed Earth's surface. We have changed the composition of the atmosphere. We have altered the chemistry of the oceans. And by we, I mean all living things, not just humans, right? But life has substantially changed Earth. And once again, right, plate tectonics are not just changing the location of the of continents, they're also changing the location and the size of ocean basins. So oceans are forming and then shrinking. Continental land is forming, shrinking, slamming into each other, subducting, right? So geology is constantly changing. These tectonic processes and other natural processes are shifting sea level. Sometimes sea level is a lot higher, sometimes sea level is a lot lower. When sea level was higher, many parts of North America were submerged beneath seawater. So where we are living in Georgia in the past has been under hundreds of meters of seawater. Okay? An example of how different Earth's surface used to be is that during the Cretaceous, plesiosaur dinosaurs actually lived in what now is Kansas, right? Plesiosaurs live in the ocean, by the way. So Kansas used to be underwater. So sea level and fall and rise is not just recorded by where we find marine fossils, but also in the sedimentary sequences that we see that are bounded by unconformities, right? The sea level rises, deposits marine rocks, marine sedimentary layers. The sea level falls and erodes the surface, creating an unconformity. And this happens over and over and over again. So in the rock record, we see these periods of sea level rise, sea level fall. And right, we've talked about the rock cycle, how we have these different types of rocks, but any rock can become a different type of rock if it undergoes different processes like heat and pressure or melting or cooling or erosion, right? So just one more way that the Earth is constantly changing. Hopefully I've driven this home enough that in all aspects, right, the atmosphere, the ocean, the land surface, the composition, what rocks are there, what life is there, the Earth is constantly changing.